All right, here we are with Jason Chandler of the Portland Jewelry Academy, and we're going to do a not live. This is all pre-recorded. In fact, we're going to have a pre-recorded video in the pre-record that we're doing right now, and and it's going to be great. This is going to be great. You recognize that? From any place. So what we're doing is a demonstration of stock making. In other words, sheet and wire, as I understand it. Jason is the director, instructor, and owner of the Portland Jewelry Academy. Has many years at the bench and is probably one of the most knowledgeable people I know about everything bench wise. And I'm proud to say that we've been friends for a while here too. And he's a pretty good guy overall. So Jason, you want to, before I switch scenes to the video, is there anything that you'd like to talk about with
Well,
regard to? Sorry.
I just got this video recorded and edited. I'm a bench jeweler, not a videographer, so we're going to see what we get together. I didn't make any sheet in it, and I may stop it at time to time just to explain a little bit. I'm going to try not to go on tangents, which everybody who knows me is a huge feat for me. But it's the basics of making stock, which it took me years of figuring this out. There's a lot of misinformation. There's just flat out misinformation on the proper way and things to do. Some of
Absolutely.
it, yeah, a lot of it is handed down black magic from generation to generation. One generation teaches it to the next just because that's what they were taught, not because they know why. So there's a lot that I'm probably going to leave out, but that just means more content for later. It's actually can be a pretty deep in the rough sort of when you get into the metallurgy and the copper versus silver and all of our alloys, things of that nature. It can get in the sticks. It can get deep in there. It's people who give you simple answers as to why you have problems with casting or pouring ingots, making stock, usually are oversimplifying. It's there can be multiple reasons. Anyway, that would be a tangent. Um,
Yeah, I'll try and keep you on track. I've known you long enough.
I'm not good. I'm not going to make sheet in this one.
Okay.
I'm just making wire, or not even wire, square stock. But what I'm doing is I'm maximizing my return. So I'm pouring, in this case, it's a 10 pennyweight, a half an ounce ingot. And I am going to start rolling it down, but you'll see I'll get a pair of bolt cutters out. And when I get so much at around 4 to 3 millimeters, I'm going to cut it in half, set that aside, move to the next one. And what you're doing is, instead of taking all of your time to make one piece of stock, you're maximizing yourself to make your week's worth of stock or your day's worth of stock. So you're only pouring one ingot. You're only, you can always take it down to something else. Like a 3 or 4 millimeter stock, I can turn that in really quickly into 4x3 rectangular stock for sizings or bezels. 1x3, excuse me. Or I can take it down to a 2x2. Or, the further you take it in the process, the less you're able to do with it without melting it into an ingot again.
Mm-hmm.
And that's the point I'm trying to get across.
Right.
In a future episode, I'll, after we get these basics out of the way, we can start working on more complex issues. I can show you how to pour a 3-ounce piece of stock to work with. There's some different techniques for that. And in another one, I would like to show the sheet methods, because there's a little bit of difference there.
Okay, cool.
But
approximately how long's the video? Just for a heads up.
I think I got it. Okay, let's see, 9 minutes.
Oh,
9
okay,
minutes.
perfect. Great. So that's
9.5, so 10 minutes.
all right. Well, let's go ahead and change scenes here in OBS. And now your video is up on the screen. You're a little guy in the corner right now. And go ahead and start it, and I'll let you narrate.
Okay. So what's going on here is this is my ingot mold. Now I'm going to be using a closed ingot mold. That's what this guy is right here. These ones back here are open. They're more like a bread loaf, you know, when you pour them. The main difference between them is how the crystals are formed. The crystals or the grains in the metal are always formed from the places that cool to the last place to solidify. Now, what I'm doing right here is I'm putting a good layer of soot from that candle on there. A lot of people use oil. That's not the best idea. I learned from one of the metallurgists at United, the oil can get actually trapped in the grain areas, the hydrocarbons, causing defects. Also, it can catch on fire, just like black powder in a bullet, and push your metal back out. So the safest and easiest, really low tech, is just to have a candle around and put a layer of soot on there. If you use propane or acetylene, you can actually use the torch to put the soot on. Now, what I'm going to do is preheat the ingot. Now, this is the first area there's a lot of misconceptions about. We're not actually heating this up. I mean, the difference between well, we are heating it up, but that's not our primary purpose. Our primary purpose is to dry the ingot mold. Now, if you look carefully where the torch is on that cast iron, I'm putting my finger through it, that's water. Water condenses onto that iron ingot mold I got a little close to the torch there, because it's a product of combustion. So water is produced in that flame, and you can really see it, the dark spots there. So that's your indicator. You want to watch. It took me 20 years to figure that bit out. You want to watch deep down in the corner there. That's usually the last place to dry out. And that's what I'm doing. I'm heating that up, but I'm watching for the water to dry. Once that is dry, you're golden. You're done. Now I can assemble it. I did a quick edit there because I had to go get my melting crucible. But I put that together. You can tell it's a little warm because I'm just using my fingertips. I've got some pretty heavy calluses over the years, so don't feel like the fact you have to use gloves or a hot pad is a problem. Now I'm using my melting crucible close to the ingot mold so it stays warm as I'm melting my metal, which is in that cup right there. What I'm going to use is a flame that is just on the reducing side of neutral. So you have three basic flames. The most solid flame, the one that's right in the middle, kind of the zero of your number scale, is a neutral flame. That is one where you have an equal amount. Well, I'm going to see this way this is flowing here. I'm letting oxygen in at that point, and I don't want that. We want our flame to come straight back at us like this flame right there, so that we don't get any oxygen from the atmosphere in there. Now, I'm going to make a neutral flame. I'm going to restart it. I'm going to make a neutral flame here. And like I said, I just rough edited this. So a neutral flame is a perfect chemical balance of fuel and oxygen. Neither one of them is left over. While I preheat, I'll talk about your other flames. Everything on there's extra. I'm actually going to pause this just for a second because it's not going to take long for this to melt. Everything that is on the extra side of fuel past neutral is a reducing flame. Different levels of it, but it's a reducing flame. There's more fuel than oxygen. Everything that's before that, where you have more oxygen than fuel, is an oxidizing flame. We may use an oxidizing flame for platinum work, but for gold, silver, copper, we use a reducing flame, but we want to be not very past neutral. I see the students all the time get worried about overheating the metal and go pretty far past to where they're actually cooling it off, and they're not using that full force of the torch. We don't want to take a lot of time melting this, but we want to melt it in an environment where there's a little extra fuel, and that's because that fuel is going to protect our metal from the atmospheric oxygen. It's more reactive than the metal is, so it's going to combine with that oxygen rather than allow it to combine with our metal. In silver, that's very important because silver will absorb many, many times its weight in oxygen. And as soon as when it's liquid, but as soon as it's solid, that oxygen comes out. And anybody who's ever rolled out a thin piece of silver and then went in and annealed it and had bubbles come out, it's literally the oxygen gas that's trapped inside that solid ingot expanding, just like blowing glass, and it expands and makes a balloon in there. A little bit doesn't hurt the metal. You can just trim it out and use the rest of the metal, but repeated is going to start causing some damage to the metal. Now, the flux I put on there is about a 50-50 mixture of boric acid and borax. Those are two different elements. Boric acid starts working at lower temperatures than borax, but the borax continues to work at higher temperatures after the boric acid is done doing its job. So mixing the two together gives you a longer range of protection. Excuse me. So you put a good rule of thumb. I like to pinch. I like to cook. So I like to pinch my borax on. I don't like to just sprinkle it in there willy-nilly. You want to use enough to do the job and not too much. And if you think of it as an American Heart Association recommended amount of salt per a bite of food, that's about the right amount of borax or flux. Okay, so let's go ahead and melt this. I did put a polarizer. Obviously, I need a stronger one to be able to see through that flame and see that melted. What I'm seeing that you can't because of the limits of photography is that deep down in, I've got some safety glasses that are shaded. I can see the liquid metal. And right now I'm shaking it, getting it to roll around. It should be fluid. And now what I'm showing you here is that you move the torch and the metal at the same time. And in one clean pour, unfortunately, you can't see it until I get the right polarizer. It goes into that ingot mold, not in drips and not all at once. You want a clean, smooth pour. It takes practice to get that. Now I'm going to open it up, and you're going to see it's got a pretty tight grain structure to it. That's the crystals you can see in the surface. And that little bit of flashing on there, that's super thin. You can see some of it came off in just my fingers. Depending on the ingot mold, I probably need to clean it a little bit, but that's not going to hurt anything. I took a file, a really light file, just cuts that off. I also quenched it to make sure the grain was done growing. Now I'm going to start hammering on this. I'm going to move a little, that's just a cheap anvil over, so I can hold it off to the side. And it's important to use a ball peen when you hammer this. Now, I should have a small, inexpensive ball peen. And we want to make nice, deep dents all the way around this. When your ingot cools, those grains are going to form in a logical pattern. They can even form just like columnar basalt. Think of Devil's Tower in Wyoming. And that produces logical pathways, or like a brick wall where all the mortar joints line up instead of overlapping. By hammering the ingot, and it's more important in high copper alloy, so the silver we're pretty safe with, but still it's worth doing. Hammering that ingot breaks up and redirects those grain area boundaries so that as they grow, when I eventually anneal this, they do grow when you anneal them, they grow interlocked and overlapped. It's a lot like the difference between regular lumber and, I'm going to speed it up here real quick here, but we're going to see how fast I did it. It's a lot like the difference between plywood and regular lumber. Plywood, the grain is overlapped, so it goes in different direction. You never see karate demonstrations with plywood, and there's a reason. Now, I have the luxury of a roll mill that is just for square wire. Basically, what that means is I just don't have to adjust it as often. So most people are going to have a combination mill. This is one where some of it is flat and the rest of it is wire. The process is the same. You're just going to have to adjust it more often per a hole. For most of my holes, I only have to adjust it once. But for each adjustment, you have to go through twice. And what you'll see as you're watching, what I was explaining earlier in the video, is that it only compresses from the top to the bottom, right? It only squishes it. If I could, there we go. My fingers are up in the small box. It only squishes it this way. It doesn't squish it this way. So you have to rotate it every time you go through to make it even. And you have to go through twice for every adjustment. So where I have to adjust once in my slots, I have to go through 4 times for each slot. Once when I open it up, or twice when I open it up, excuse me, and then twice when I close it all the way before moving on to the next slot. Man, I am really good at this. Look at how fast I can turn that. I should hook up a generator to it.
Drink coffee much?
Anyway, so I'm measuring it because I want to keep track of it. When I get it down to about 50% reduction, then I want to anneal. Notice I have not annealed this yet. And this is doubly true for white gold. The biggest mistake people make with white gold is they anneal it too often. They get a crack, so they remelt it, and now they're annealing it 10 times over. Now, when I anneal, notice the color of the flame. Let me see if I can pause it when it's, there we go. Nope, I missed it. Oh, it's like one of those Instagram games. Let me take it back here and try it again. Just look, so the yellow, look at how yellow the flame, see how yellow it gets? That's when you're at temperature, when that flame turns yellow afterwards. So the other thing I did there is I held it at temperature for a while. A lot of people don't hold it at their annealing temperature long enough. It's important that you get that temperature to soak all the way through. You don't want to overheat it, get it too hot, but you want to make it embarrassed, red, nice embarrassed, but not quite till it's angry red. So get it red, and then take the flame on and off until you keep it at that red. Now, what you see over here is I've already cut this ingot down twice, and now I'm working on the last bit. I'm about to get it to the last wire. I didn't take it past this. Oh, look at that. This is the washer slipping that's holding my polarizer on. Causing a vignette there. Great video, huh? But what you'll see here now, and it only took about 15 minutes for me to do this. But I just, made some, I think about 4 millimeter square, some 2 millimeter square, and then a couple of feet of 1 millimeter square. If I was making, say, some prong wire or tipping wire, I would have cut this in half and then drawn that down, which would have taken another, 10 minutes at tops. And I just made a whole bunch of stock. And there's a video.
That was great, Jason. I'm really impressed, and I think I learned a bunch myself. I have a couple of questions. First of all, clarifying, we were rolling silver there, right?
Yes, this was silver. This was a silver ingot that I did.
Okay.
The process that I did with this works for white gold, works for rose gold, yellow gold, silver. But the biggest difference is the resistance that you feel on the handle. So one of the things I try, like I do with my students, if you're just learning how to do stock, the best thing, or one of the great habits you can get in, is every time you anneal that stock, bend it a little bit afterwards. Mm-hmm. Just bend it in your fingers. Get the resistance feel for that metal when it's annealed down. That'll help you, because we don't work in a laboratory environment. So what that means is that, what works on paper, a hard number, if you read information on, anneal to this temperature for this amount of time, which is how the large manufacturers do it. It's a time and temperature thing. They can do that because while they have it in a kiln for a half an hour, they're working on some other ingots. They're working on other stock. Mm-hmm. We're bench jewelers. We're making jewelry. It's not about making stock. It's about making jewelry. And you got to keep that in mind too as you're making the stock. I'll explain a little bit more about that also. So if I can get my brain back on track here.
Let me distract you with a
Go
question,
ahead.
and that maybe you can get it back. The big thing that I noticed, I've used a rosebud for
Mhm.
melting precious metals forever, and I never really understood why people used a single tip torch to melt with. So
That's a really
is
good question. Yeah, I have both. Um, that single tip torch that I have, that's like a Victor number 7 welding tip, might be number 8. It's
Mhm.
really big, even as a welding tip.
Yeah.
So, the hole in the end of that is not one that you're going to find in your regular just buy a welding kit from Harbor Freight
Hmm.
tip. So as a welding tip, it would be massive, specialty tip to begin with. Um,
You could totally see
but
that. But yeah, go ahead.
so, well, I like it because in order to get the heat out, I can get a better reducing flame with my setup of natural gas and what I'm working with that single orifice than I can with the rosebud. The rosebud in my system, I have to add a little more oxygen to it than I'm comfortable with to get a stable flame that has the heat where the melt is. I do use the rosebud, but it's not until I bump up to 10-ounce castings.
Hmm.
I think the largest casting I can do is somewhere around 16 ounces, uh, which is really really big. um, you know, Maybe if you take a minute here, I'll go get my crucibles to kind of visualize the difference there. But for my normally I'm casting, 1 ring, 2 rings, maybe 3 at a time.
Hmm.
So most of my castings are 5 ounces or less that I'm using with my torch. So in my system, I just get a little better cover gas that I'm really paying attention to that gas that comes back out, that flame that's coming back out. I'm also paying attention to the hot spot. The next time you're preheating a crucible, play with your flame a little bit, and you'll and pay attention to or your oxygen fuel mixture in your flame, and pay attention to where the glow in your crucible happens. And you can totally like turn that torch up to where you're throwing more fuel and oxygen. You're flo- throwing a larger flame out of it at it, but it's coming back out, and all the heat is actually happening outside of the crucible.
Uh-huh.
But paying attention to where that glow is, you'll find that there's a sweet spot on every torch and every tip where you get that glow, that hot spot to be centered in where your melt is.
Right.
And so um, I've tried several times actually to go back to rosebud. I learned on a rosebud. I used one for years, um, but I just get more control out of
Okay.
that single orifice tip.
Yeah. Good. Good
Um,
answer. I melt mostly with hydrogen to help prevent, oxygen. Well, it's still an oxygen torch too, but and then I think it's a MFA 1 Victor, huge rosebud, but it turns down
yeah.
pretty low. So
Well, now you mentioned hydrogen, I'm going to say that I have tried hydrogen is a fuel like melting platinum in that. I prefer the rosebud with hydrogen.
yeah,
So that's interesting. That's a good. I don't use hydrogen that often. I only use it when I'm casting platinum, which I don't do that often. Here in
right.
Portland, we have Tech Forum just down the road,
Hmm.
and they do such a good job. And then uh, when I'm casting just for myself, I really enjoy casting platinum, but there is a higher percentage of defects, and the defects that are happening with platinum generally, I don't mind fixing them because I enjoy working with platinum. I enjoy the process.
Right.
Um, but when I'm casting these days, I am casting, and then one of the jewelers in the trade shop is filing it up. And so I would rather pay a little bit more and have Tech Form do it because I know that my mistakes are not costing, you know, that's the problem, so I cast with the platinum, and then I hand it off to one of my jewelers, and I'm just not comfortable with my mistakes costing them
Yeah.
time and therefore money. So I haven't cast platinum for a while because of that. I really enjoy it. It's so much fun. It's an adrenaline rush.
It is an adrenaline rush. Oh my God.
Especially, with a torch. And, I mean, the last effort before you cast is punching the machine,
Yeah. With the potential of breaking your arm and burning
right.
through it.
It's it's a lot of heat. It's a lot of noise. I mean, you can feel it. You've got a nice rosy glow when you're done.
Yeah.
And the icing on the punctuation is a punch to the machine to punch and a jump back.
Right.
So, anyway.
Well, you know what? I think this has been an absolutely fantastic video. Your depth of knowledge here is very impressive to me. And this, folks, is a really good reason why you should, if you're interested in a career in the jewelry industry, the Portland Jewelry Academy is, in fact, an Oregon State accredited school, which means a lot, actually. And Jason worked a long time to develop a curriculum that works, and I think his graduates tend to get hired. My understanding.
We have a good hire rate. Yeah.
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 So you're doing.
Thank you.
Well, yeah, you're doing a real service to the industry, I think, and you're doing it in a very professional manner. So anyway, this is, unless you have some closing statements, I think we could probably go ahead and end this for now. But let's do more sessions. I'm really happy with the way this one's going, and I think that our video quality in this case worked out really well with you pre-recording part of it and then bringing that in a separate scene. I think this all worked really well. So you know what, if you watch this video, give us some feedback in the comments. That would be really great. If you like this content, please give it a big thumbs up, and don't forget to subscribe for more quality content from the Benchworks podcast.
Yeah, hopefully I can get a polarizer that lets us see that melt.
Yeah, that'd be very cool.
I'll figure that. I'm assuming it's a polarizer. So there's another thing for your comments. Somebody who knows more about photography than me can help me get past that flame glare.
I was questioning that myself. I'm not 100% sure polarizer is the right answer. I would start by putting like just a really dark, a number 13 lens or something, like for arc welding in front of it, and
right.
then you could probably see it. Like I said, I'm not 100% sure polarizer is the right answer, but it may be. I mean, it would bear some research. But I think just if you have a arc welding helmet there, have a helper hold that over your camera when next time you're melting.
Maybe stuff. I can hook up a screen, a picture-in-picture.
You know what? We could CAD up a little flip device that your screen would fit into. So when you start melting, you could just flip that down over the lens.
There we go.
I love it.
But I agree. I think we should do more of these. This is just a scratch of the surface of where to go with this, and it's an important topic. I just want to add before we completely close that I have my own personal experiences that the industry has asked the wrong question regarding making stock, and that question is whether it's cost effective to do it or not. And if your goal is making stock, then no, in most cases it's not cost effective. But we're jewelers. Our business is not making stock, it's making jewelry. And for each individual job, you need to be asking yourself, does it make sense to make the stock or buy the stock for this? And you'll be surprised when you start asking that question, how often making the stock is the right answer. It can keep a lot of money in the bank.
Well, let me add to this, too, and that's something I mentioned in several previous videos that we've done here, the cost of holding inventory. So if you buy stock from a refiner, you've got to buy half I don't know, maybe 10 different types of stock, square stock, round stock, different sizes. half round stock, all that stuff. But if you have the ability to make this in-house, you can just hold a relatively smaller quantity of pure gold, make your alloy up, and there's another video, make your alloy up on the fly and make just the right amount of stock that you need for that week, or as you mentioned, that week, that day, sometimes even that hour. Uh, in
Oh,
in
absolutely.
in one of the last videos I did, I showed how to what I call pinch loaf, to just like you don't
Yeah.
have the right stock, so you just use your tweezers to pinch a loaf just the right size to roll out just enough stock to do a half shank, that kind of thing.
I do that all the time. We talked about that before, and I love the term pinching a loaf because
Yeah,
it is exactly what you're doing, and you can do it at the bench with your bench torch. You don't need a big system and an ingot mold and all that.
right.
So
Well,
anybody who
anyway,
hasn't watched that video should, for
yeah,
sure.
in terms of cost effectiveness, you really have to calculate in that opportunity cost of having so much money tied up in all the stocks that you might need from a supplier, and you're paying a markup from the mill house or from the refiner that's
Yes, you
creating
are.
that for you. Yeah.
And Altoid tins do not give interest.
What was that? Altoid tins do not.
Altoid tins do not give interest. That's an
Oh,
inside bench joke because everybody keeps their stock in an empty Altoid tin.
yeah.
Uh,
Okay. Yeah, they don't
so
pay interest.
yeah,
Okay.
it's a good joke if I have to explain it, isn't it?
Yeah, that balloon didn't float, buddy. But all right. All right, man. I really appreciate this. This is great. We'll do it again, and let's stay online for a second, and we'll just do briefly. I'm going to stop recording
Perfect.
now. Bye, everybody. Don't forget to like and subscribe.